last time I checked, internet is available. So. What's the question once again, quickly? So the question once again says, if z equals cis theta, find the argument. You don't have to copy the question again. Find the argument of this particular one is I divided by cube root of z. That is the B part that I asked you to try to complete on your own yesterday. So as at yesterday, we already agreed that this is the same as z to power negative 1/3. Yes? And also, we agreed this is I into bracket cis theta negative 1/3. Yes? And this is not like binomial expansion with negative fractional power where you think you can expand, even though that cis theta is a binomial. But we learned something yesterday which will help us simplify that further. What is that? What will help you simplify this further? What do we call it? We learned that yesterday. Didn't call anything expansion yesterday. The Euler formula. This is why you should review your notes after you leave the class, so you don't come back the next day and say something off point. So Euler formula makes us realize this is the same as e raised to power what? What? I theta. So Euler formula makes us realize e raised to power I theta. Yes? And with Euler formula, we have that by the law of indices, this is simply e raised to power minus 1/3 I theta, isn't it? So this is where we kind of get stuck, more or less. Or we can go further by saying this is e raised to power ai cis minus 1/3 theta. Yes? Or theta over 3. Is that correct? So this is where we stop. So I ask you to try to go further. Can I have suggestions, please?
Put the I outside first and then do the bracket cos that bracket thing plus I.
Come back again. Yes. Like repeat what you said.
So I, then open bracket, cos bracket negative.
So you're saying we should have I cos that, I sine that. Yes? Then open the bracket. That was the attempt we did yesterday, and I said that is wrong. It is wrong because we need the argument. You can extract the argument if you can write it as maybe cos phi plus I sine phi, right? If you can write it in this form, what is your argument? Talk to me, please. Again? Phi will be the argument. So it has to be cos with I being on the sine. But if you do this, if you open the bracket, the cosine takes the I, sine becomes real. So this is not the approach. You can only take your argument if you have it in this form. Or if you have it in this form, exponential I theta, then this I phi, then phi is still your argument in that case. Once your I can stand alone, any other coefficient of I on the exponential becomes your argument. So you need either this format or this format to get your argument.
Can we do the multiplication of complex numbers?
That is it. Is I a complex number? Question, please. Is I a complex number?
Yes.
Can I be written as CIS? Yes? Talk to me. Can you write I as CIS of something? Oh my God. Can you say something? Yes or no? Can I be written, Karen, does it know you mean you don't know what I'm saying or you don't feel like talking? Because I didn't hear any of you here except I think him. Can I be written in form of CIS? Or we don't know what CIS means? Do we know what CIS means? Can I be written in form of CIS? Good, that's my question. Is this a complex number also? In form of a CIS? You've learned something about the product of two numbers in form of CIS, haven't you? What happens when you multiply two numbers that are in form of CIS?
Oh, the modulus becomes the first one multiplied by the second one.
Good.
CIS is first plus second.
Not the same. You mean the angle?
Yeah.
Yeah, the argument is, look at the notes. There was a note yesterday after we did the correction. It was on this part of the board. After we did the correction, I put a note. What does the first note say? Speak louder, please.
To multiply into complex numbers in polar form, multiply their absolute values and add their arguments.
That's it. So these are two complex numbers. This is already in polar form, but this is in what form? Cartesian form. So what should be your first thing now? Change this to polar form as well. Your result is only the argument. So irrespective of what the modulus is, you don't care anyway. And we are lucky, the modulus of I is what? 1. So it's just like this one. Somebody was asking yesterday, and I said something about why I'm not putting z absolute value of z. Because this already, they told you that definitely z has absolute value 1. That's what it means. You're not supposed to put any other absolute value there. So that's what you should do. So there are two complex numbers now. I and that. So this is my z. In fact, what you could do is not even get to this point. At this point, you can call them maybe W1 and W2 and apply that law. Or you can still do it from here. So I'm going to call it W1 times W2, where my W1 is just I. Does it make sense? And the absolute value of W1 is just the square root of 1 squared plus 0 squared, or 0 squared plus 1 squared, if I put it in order. Does it make sense? Do you know how I got this? Because this is 0 plus 1i. And the absolute value is definitely 1, like he said. For the argument of I, argument of W1, okay, that would be the arctan of b over a. That's 1 over 0, which does not exist, right? So what angle would that be? 0. No. 90. Tan 90 does not exist, so that must be pi over 2. Which means the polar form of I, so W1 is, the polar form of a complex number is absolute value of the complex number, then CIS of the argument, right? So this will be the absolute value of that, then CIS of the argument. I call it phi because we're already using the variable theta. In this case, it will be just 1, the absolute value is 1, and CIS what now? Pi over 2, which is simply just CIS of pi over 2, because 1 is a multiplicative identity, there's no need to appear. Right? So now, you have two complex numbers in form of CIS. Now you can use the property of CIS. So the original question, I divided by the cube root of z, which you have successfully reduced to this form. ICIS, I will say negative theta over 3, right? You have successfully, so this is from here, and this is where we stopped. We just like diverted a bit, okay? We just like move out of the original solution because we need this. That's why it has to be shown, okay? This can now be written in the form of two CIS. Tell me. Pi over 2, CIS, negative theta over 3. That's what we're saying. Now, by the property, what does this give you? CIS, pi over 2. That's it. So if this question can be written as a CIS, what is the argument? Just the one in the bracket. That's all about the question. So argument of I divided by cube root of z is then pi over 2 minus theta over 3. That's it. To pick your argument is to write it in this form. Then this angle becomes your argument. If it is not in Cartesian form, make sure it's in polar form to pick your argument. You need to do practice. You need to stop going home without at least spending 5-10 minutes. Even 30 minutes is enough to just look at some questions at the end of school. Any other question from what you must have practiced? If you haven't practiced it, I won't attend to it. I need you to practice it first and tell me where you get stuck. Yes. 5B, have you made an attempt?
Yes, I'm not sure what did I do.
Can I see first? Then I can. What does the question say? Somebody remind me.
Evaluate 3 to the power pi.
Evaluate.
Just about, right?
Oh, 3 to the power I. Okay,
Yeah.
now I understand. Five B. So it's to evaluate 3 to the power I. Yes?
Yes.
That should be easy. Any idea? Which of the forms of the complex number we have learned you think is easy to manipulate powers with? The Euler form. So that should be your target. What do you change to Euler form? 3.
E to power
No, I mean, what do you change to Euler form? I thought you said 3. Did you say 3 or E? 3, yes. Change 3 to Euler form. And it comes with I. So 3 is going to be exponential I something. Right? Then raised to power I. What does that tell you? Again? I squared. I'm going to include your name on the list, Leo, for making that attempt. So that's going to be I squared with that angle. Right? What does that give you? -1. So that's exponential minus that angle. Okay? So, what is the angle? You need to find out. Then you can write it as CIS of what? The negative of that angle. And you can evaluate that. And that will give you the result. That's it. Just that.
Okay.
So your goal is to make sure 3 can be written as Euler form. When dealing with powers, think of Euler form. Because that's the one that gives you something you can manipulate with powers. I believe everybody knows how to put 3 in Euler form. Right? Yes. What is the first form you go to? You don't even need to go to any form first. You can go straight to Euler form by finding what? What does Euler form of the complex number mean? The Euler form of the complex number say the complex number can be written as this. Yes? Yes? And where did you get this from? Because the polar form says you can write it as this. Okay? From where does this come from? Because in Cartesian form you have it in this form, right? From here you can get absolute value and you can get theta. From this form, because of the Euler identity, this can be written as this. Okay? So which means even from here you can go straight to this place. You find the absolute value, that's here. You find the argument, that's the power on one of the powers on exponential. Does it make sense? That's it. So do that to 3, just have to show your workings and substitute into this calculation that I did. And that will solve your 5b. Any question? Who does not understand what I explained over there? Karen. Okay. Which of the parts?
How did you change 3 into 4?
Okay. So I'm trying to capture where I'm going to write so you can review that later. So again, I didn't change it. I'm only telling you what to do. You have learned that if you have, now is 3 a complex number? Let's start with that. 3 can be seen as a complex number. It's just the real part, right? There's no imaginary this time around. Because 3 is a complex number, 3 can be in this form. I'm trying to review what we have learned so far. If you have it in this form, what is this form called? Cartesian. So if you have it in Cartesian form, you can either change to this or this. What we learn, what we build over time is that if you have it in Cartesian form, you can get the absolute value and can get the argument. And that tells you the ci theta. That gives you this format. Then yesterday, in fact from your previous assignment that a group solved yesterday, ci s theta is the same as this, the Euler identity. Okay? So with that, we are able to get the Euler form of a complex number. So I'm trying to say you do not have to go from here, get this first, and get this first. You can actually go straight from here to here. Okay? Get the absolute value, that's this one. Get the argument, that is the power, just right beside I on exponential. So, from this Cartesian form, you can do this, correct?
So the argument is
Theta, this theta is here.
oh.
So this same theta is what we put here. And what does this theta represent here? What angle? What is that called? What's that called? The argument. So the argument is the same here. It's not a new variable. When this group did something yesterday, they were able to prove that exponential I theta is indeed cos theta plus I sin theta. Do you remember? This I is still this I. This theta is still this theta. So which means the argument you are dealing with here is the same power on the exponential right beside the other constant I. Does it make sense now? So from this point you can go straight to this one. Your 3 is in this form. You can write it in this form. Once you write it in that form, then put it in a bracket.
Wait, 0, so it's 0, 3 plus 0, I.
Yeah?
But there's
Then how do you find the argument?
power. They're just
There's what? What do you mean?
Then what's the argument?
What do you think is the argument? Let's put it on a diagram.
Okay. Then if the argument is 0, then there's no I.
Yeah?
oh, this is
Yes.
I think the confusing part is just the power.
Yes.
So there's no I.
Oh wait, I think I get what you're trying to say. It's coming back to 3. Is that what you're trying to say? Another I is coming up?
If you get the exact same thing.
The modulus is part of the 3, right?
Yeah. So what will be the modulus? The modulus remains 3.
Yes, and
And your argument...
Wait, why is the modulus here when there's the power of
No.
For just
We are
3.
trying to
For
just
just 3.
work out 3 first.
and then since the modulus is 3, the I power also affects that 3. Isn't it?
Yes. Because, yes, if you put it in that form, you're going to have this exponential I theta, then everything raised to power I, basically.
Oh, so we're going
Yeah.
here for now.
So it's coming back again.
Yeah, there's another 3
Ah, I
That's the
see. I see. Okay. So basically, I'm going to have 3I equals another 3 exponential, actually 0. Because the argument is 0, isn't it?
Yeah.
Ah, so it comes back to the same thing.
Yeah.
Oh, I see your problem now. I see your problem now. So this won't work, basically. That will work for an ordinary complex number like maybe I. Maybe like I raised to power I. That's when this will be more useful. This approach will be useful when you have I raised to power I. Do you understand what I mean? So in this case, let's think. So, suggestions, what do we do? Come on, let's think. Think of another thing that we have done that could be used. This is what I'm trying to tell you here, which of course does not work for the case of real. If you have I raised to power I, then this is useful. If you have I raised to power I, your argument will be 90. You agree? For I. So that becomes exponential I theta will be I pi over 2, then raised to power I. That's the principle I'm trying to explain here. So exponential negative 1 pi over 2. Yes? That becomes cos negative pi over 2, then I sine negative pi over 2. Yes? Now, cos 90 is equal to what? 0. So cos of minus 90 is also 0. Sine 90 is 1, so this is just minus r. Okay? Evaluating it means just getting, you don't have to have like a sort form or anything. Okay? So, what can we do when it is real? What did you get? Cos 90? 0. In that case, you use pi, you don't use 90. I just said 90 because I'm used to 90. Like degree mode. 3 raised to power I. Yes? Actually, there are. What is the first question in this one? In 3, 5b?
5a is e to power I.
5a is what?
E to power I.
Yes, it's power I. Were you able to do that?
Yeah.
Okay, oh, I just did I raised to power I unknowingly. Did I give you 6c?
C was like.
Did I give you that to do?
Power I, power 2.
Okay. So there are i's of i's of i's of I like that. Alright, that's fine.
6 is the
Which other form can we use then? This apparently will not be a way out. And this is not like a product of multiple complex numbers. What do you think, Mr. Nice? Looking at the time here, so in the what?
That form,
Which form?
the cos something plus I.
Okay, so the thing with that is you have a 0. The angle for with the when you change your 3 to polar form, you get pi theta to be 0. So that's like cos 0 I sine 0. Cos 0 is 1. Sine 0 is 0. So you are just coming back to your 3. That's why that doesn't work. Okay, so look at this. If you have 3 will be absolute value of 3 exponential I 0 definitely. It doesn't make sense. If I do I here and I here, this is gonna come back. and this doesn't affect anything. Minus 0 is still 0. Yeah. Even if you do that, Leo, and you put this as I, this already is not CIS anymore. It's just 3. It's just 1, I mean. So we have to think of something else. Okay, so this is what I would do. I'll have a look at that. I need you to attempt the orders. So exponential I shouldn't be a problem. Yes? I raised to power I has just been done. Mistakenly, actually. I didn't know I gave you that. D is I raised to power I, then raised to power I, then everything raised to power 2. Make an attempt on that. Question 7. Were you able to attempt? Do you have any question with that? Oh, maybe I call it question 6 on the board. The one I asked you to prove something, I mix questions together. Can I see anybody with that? Okay, were you able to? You haven't got time to do it, or you don't know what to do? Okay, so I won't do that 6 yet. I need you to make an attempt. When we come back on Thursday, then we can look at it together. Also, this 3 raised to power I question, the approach I ask you to use there is actually for a complex form. It doesn't apply to real, as you can see. We keep coming back to the same thing. Think of another approach. Otherwise, when we come back next time, let's do that also. We have about 7 minutes, and I need us to quickly be introduced to this de Moivre's theorem. Then we can apply everything. Next lesson is a double lesson, so it is my wish that we move beyond de Moivre's theorem and move to the roots of complex numbers, which is the last section of it. But we may not complete it until Friday because I wanted to do a lot of practice. And having said that, get ready for random tests. It will be short, it's not going to be long. I want to do maybe about 2 tests on complex numbers. We can divide it into sections for conveniency. And of course, by the end of term 2, you still have to have like a general test anyway. Then maybe sometime next week, one of the double lessons, we do the correction of all the previous stuff that I've been talking about. We have a double lesson on Monday. Monday might be the best time. If we don't do it on Monday, it will have to be Thursday of next week. I want it to be on the day we have double lessons, so we have enough time to go through those questions. So quickly, we may not be able to do this, apply this. What is this idea of de Moivre's theorem saying, really? When you have powers of complex number, particularly higher powers, actually de Moivre's theorem, we have done it before. I'd like to give you a question to start with. It's actually one of the exercises here. Everybody, please attempt this. We have less than 10 minutes, so I need you to be fast. Attempt that in about 5 minutes or less.